Good afternoon, pilot teachers, and good afternoon, students. Okay, thank you. Sit down. Okay, we're still looking at information on chemical weathering, and today we'll move on to looking at some more examples, especially on chemical weathering, and then perhaps in our next lesson, then we will move on to looking at the last type of weathering process, and that is the biotic or biological weathering process. Okay, recap now on what we have covered, especially on weathering. Note, we were told, and also we've looked at the information on weathering as chemical weathering as the disintegration or decomposition of rocks caused mainly by a chemical reaction. And we also noted that there were 4 examples that can come under chemical weathering, and the 4 examples are solution, carbonation, oxidation, and hydrolysis. Our last lesson, we looked at some of the features which are actually formed as a result of chemical weathering, and especially looking at the example on carbonation. We were given a couple of activities, 4 activities to work on, and due to time, we were not able to correct those activities together in class. So for the first part of our lesson now, what I'd like us to do is I would like us to go through the correction of those 4 activities that you were assigned to complete for your homework. So could you now check on those 4 exercises that you were given, and we'll check also for the answers and do corrections together. Okay, recapping on those questions. The questions are, number 1, you were supposed to explain the formation of stalactite and stalagmite, or stalactites and stalagmites. Then number 2, you were asked to define what a karst scenery or topography is. Number 3, you were supposed to explain and also list some common features that we looked at of a karst scenery. And finally, number 4, you were asked to define the word or the term door line. Okay, we'll look at the first one. Explain the formation of stalactites and stalagmites. Gibest.
The stalactites and stalagmites are formed from the deep stone cave-in when drops of water enters the cave hole, then forms pointy rocks from the ceiling, which are called stalagmites, and from the base, sharp cones are formed, which are called stalactites.
Okay, we'll double check. Gibest, we'll double check on that. Double check on the information. Stalactites, where are they supposed to be formed from? From the base up or from the ceiling down? From the ceiling down. Okay, so stalactites are formed from the ceiling of the caves down, and stalagmites are formed from the floor of the caves, and they grow upwards. Okay, and his explanation is definitely correct. Only the correction that we are making will be for stalactites. They hang from the cave ceiling down, and stalagmite, they form from the cave floor up. Okay, you can check and do your corrections from the monitor. The answer that is given is very similar to what Gibest has given, and thank you, Gibest, for the answer. Okay, we're checking now from the monitor. Stalactites and stalagmites, they are formed from the deposits of calcite built up in the caves by dripping water from the process of chemical weathering. And that dripping water we were making reference to when we were looking at formation of dripstone or dripstones. Okay, are we happy with that answer given? Okay, good. Then we move on to question 2. And question 2 would like you to define what a karst scenery or topography is. Define karst scenery or karst topography. Susan, do you have an answer for question 2?
A landform which contains some of the common features created from chemical weathering and mainly carbonation.
Okay, very good. That's straightforward. We're looking at the landform, which is mainly created as a result of chemical weathering, especially on Carboniferous limestone. So the rocks of that area will have to be of Carboniferous limestone. When the surface is actually weathered away as a result of chemical weathering, perhaps solution or carbonation, then you have distinctive features which are formed, resulting then in the formation of a karst scenery. Okay, thank you. Well done, Susan. Let's check the answer for question 2. The question again, to define a karst scenery or topography. And it says here from the monitor, a karst scenery is a type of landscape or landform formed from the processes of chemical weathering, especially on Carboniferous limestone areas. And when chemical weathering takes place on such area, then what happens are distinctive features are actually created. The reason for why we are not giving those features now in question 2 is because in question 3, you are asked to make a list of some of those distinctive features in a karst scenery. Okay, are we happy with the answer for question 2? Yes? Let's look at question 3. Christopher, your answer for question 3. And for question 3, it reads, you are now asked to explain and list some common features of a karst scenery. Christopher, what I will want you to do is you make a list only, and then we'll get a couple of students to explain those different features that you are going to list. Okay, list down some of the features found in a karst scenery.
Absence of surface runoff.
Okay, double check. That's one. Absence of surface runoff. Good.
So soils are thin, causing little vegetation.
Okay, very good.
Swallow holes are common.
Number 3, he said swallow holes are
are-
common. Good.
Rocks are Carboniferous limestone.
Okay, rocks mainly of Carboniferous limestone.
Stalagmites and stalagmites and stalactites are found there.
Okay, definitely yes. Stalactites and stalagmites are found, but where? On the surface? Not on the surface. Underground, especially in the caves. Okay, so he's listed a couple of those features. We'll double check. Okay, we'll double check on those features that he's listed for exercise 3. The absence of surface runoff, correct. Thin soil and therefore little vegetation, correct. Caves was not mentioned, but we can include caves with underground stream or water, and also caves with stalactites and stalagmites or dripstones. He also mentioned the formation of swallow holes. Good. I have not got that as an answer on the monitor, but we can add that as F, swallow holes, which are common in such areas, the karst scenery. We also have dough lines. Dough lines are common and also are created in karst scenery. And finally, the reappearing of underground water, which are referred to as springs or resurgence. Okay, so all we are adding onto the answer from what we have on the monitor is the swallow hole. So we'll make that as F. These are all the features which are common and which you are able to find, especially on the karst scenery or topography. Okay, Shelley, can you explain, let's look at those features now. Can you explain why there is absence of surface runoff in such an area or in the karst scenery? We say that In a karst scenery, one of the common feature is the absence of surface runoff. Why? Why is there absence of surface runoff in such a region or area?
Because most of the water is dissolved underground.
Very good. We don't have the water on the surface. Most of the water is dissolved through the process of chemical weathering. Doreen, can you explain why there are thin soils and also little vegetation found within the area or the karst region or topography? Why? Help? Why is it that in such a region soils are thin and there is also very little vegetation? If we say that thin soils and little vegetation is one of the features that we look at to identify a karst scenery, why is it that such region has thin soils and very little vegetation growing? Anyone would like to answer that question? Okay, Silo will give us an answer. Yes, thank you. Why do you think there is thin soils and therefore little vegetation in such a scenery, the karst scenery?
Maybe due to the chemical rocks.
Due to the chemical rocks, more information? Thank you, Anita.
The limestone in these areas, they contain calcium carbonate, and because the calcium carbonate is dissolved, there is the soil is thin, leaving the soil thin.
Okay, very good. We're looking at the fact that the rocks are dissolved. They are not weathered in the sense that they will remain on the surface. They get to be dissolved. In solution, they get to be carried away in solution. So therefore, if they are dissolving, soils are not going to actually be left on the surface. Whatever soil is created is going to be very thin. And because of the fact that there is very thin soil, not a lot of vegetation will tend to grow in such region. Most of the rocks are dissolved. They do not get to be broken down and left on the surface. Rather, they get dissolved in solution, they are carried away. Therefore, the soils are thin. And because the soils are thin, not a lot of vegetation then will be evident in such a region. We understand that? Good. Okay, we move on. The next one, dough lines. Gideon, explain what is a dough line and how it is formed.
A dough line is a deep depression. It's usually a funnel-shaped depression.
Okay, a funnel-shaped depression. How is it formed, or how is that depression formed? Okay, Gibest is going to help. How is a dough line formed? And while we are on that, that also will answer question 4, of which for question 4 you were supposed to define what a dough line is. So we are also giving that answer, which will give us the answer to question 4. So you can double check on question 4 as well.
A dough line is a subsidence of a limestone and its dissolved surface material subside and is washed away into a funnel.
Okay, very good. Due to chemical weathering, materials are actually washed away as they get to be dissolved, resulting then in a depression being created or subsidence due to the washing away of those materials which are on the surface. Okay, and that will also give us an answer for what a dough line is for our activity 4 to define the term dough line. Simply, it is a funnel-shaped depression on the karst scenery, and not Gideon, but Gibest has explained to us how that particular feature is formed. Okay, finally we go back. We have already given answers to what stalactites and stalagmites are and how they are formed. So therefore we should know that for D. Resurgence and springs. How are those resurgence and springs formed, especially in a karst scenery? Rebecca, would you like to explain? How do you think the resurgence and springs are formed?
Resurgence is the reappearing of water. So when water goes down the swallow hole, it goes underneath and it has to come up somewhere in the surface of the land. So when the water reappears, this is called resurgence.
Very good and also well explained. Finally, Patrick, we also mentioned that one of the features that is actually formed and found in a karst scenery is a swallow hole. So Patrick is going to explain to us what a swallow hole is. Patrick, swallow hole? Okay, he's got no answer for that. Caleb, swallow hole. Pass the mic.
Swallow hole is a hole which is formed by chemical weathering.
Okay, he simply said that it is actually a hole which is formed by chemical weathering, of which he is correct. And from that particular swallow hole, any surface water gets to disappear through and forms the underground water. And as well as that, it forms the other features which are found under the surface through the depositing of calcium bicarbonate, and features such as stalactites and stalagmites are actually common. So we look at swallow holes. They are simply potholes or they are simply sinkholes on a karst scenery whereby any surface water gets to disappear into. Okay, and that then will conclude the activities or exercises that you were supposed to have completed for your homework. Okay, today we'll move on. And what I'd like us to actually do for our lesson today is more activities. You have 4 activities that you are going to do. And the 4 activities will be based on the 4 pictures which you will actually see from the monitor. We are looking at chemical weathering. Therefore, your answers that you give should be based on the context of chemical weathering. Let's look at the activities now. And you can discuss the pictures that you're looking at, and after your discussions, write down your answers in your exercise book. The first activity, you look at that picture given and you explain what do you think has happened to the feature. Again, we are looking at chemical weathering, and your answers should be based around what we have covered on chemical weathering. I'll give you at least 4 minutes for each picture. And then from each picture, whatever activity that has been assigned, you will have 4 minutes to look at the picture and then see if you can come up with your answer. Have your answers written in your exercise book. Again, you can discuss in pairs. And after your discussions, get your answers written down. Okay, we'll start now. 4 minutes for the first picture, and then we'll move on to the second picture, another 4 minutes, and etc. So we have 4 activities to look at in our lesson. It might be worth identifying that picture itself, what is it and what it is actually showing. And then from there you can be able to work out what has happened to that feature. Let's look at the second activity. Again, a similar type activity, but a different feature this time. We do the same activity or same thing like what we've done for the first one. Then we have activity 3, the third one. For activity 3, note you have a photograph or a picture of a limestone pavement, of which, if you look carefully at that photograph, you can see some examples of lichens and plants growing along or around that particular pavement. Prior to that, that pavement would have been all limestone, but something could have happened to have resulted in the split between the different blocks that you can see from that particular photograph. Okay, activity 3. Using that particular picture, what I'd like you to do is I'd like you to describe the surface of the pavement. And the surface is the area above here. Just describe generally what you can see on the surface of that particular pavement. Okay, having given 4 minutes to look at those 3 activities, the 4th one will be given to you for you to complete for your homework. So let's look at the correction of those 3 activities now. The 3 activities being that 1, you were supposed to look at the photograph or the picture that was given and then to explain in terms of weathering what you think has happened to the particular feature. Similarly for number 2 and number 3, looking at that limestone pavement to explain or to describe the surface or to describe what you can see on the surface of that particular feature. Okay, we go to question 1. Salesi, can you explain what do you think has happened to the feature as shown on that particular picture for question or activity 1? Okay, first of all, are you able to identify what the particular photograph is showing? Okay, Salesi, what do you think? What is that photograph showing?
A headstone.
Okay, definitely a headstone or a tombstone. That's fine. Headstone, tombstone. Okay, note, if you're looking at such a feature being put up to respect the people who have gone or who are dead, do you think people are going to put up the very old and headstones or tombstones that are about to actually break and crack? No. So originally this would have been a new feature put up. What do you think would have happened to it to have resulted in the creation of the cracks there you can see on that particular tombstone or headstone, and you can also see the names that have been written or the words that have been written have been or are fading. They are no longer nice and easy for us to actually look at and pick up. So what do you think would have happened to such a feature for the cracks to occur and for the names to be faded? Dorothy, what do you think would have happened to that feature?
Solution has taken place.
Okay, so perhaps if we are not really sure whether it is solution, whether it is carbonation, whether it's hydration or, hydrolysis or oxidation, we can just say that chemical weathering has actually taken place which have resulted in cracks and also the names which were once clear to have been faded. That's all we had to get down for the answer to that question. Let's look at the second activity. Bill, identify what is that feature and then explain what you think has happened to the feature.
It's a statue and chemical weathering has took place.
Okay, you're saying that chemical weathering has actually taken place. What is it that you can see from that statue that will tell you that chemical weathering has taken place?
The peeling of the rock surface.
Okay, the peeling or the removal of the surface or the painting or the coloring or the rocks itself, which have actually been built for the formation of the statue. Very good. If you look carefully too on the details of the statue, you can see the face there has already been completely removed. You cannot really see the distinctive features of the nose and the eye and the mouth on that statue. And that's simply because of chemical weathering which have actually removed those distinctive features on the statue. Okay, finally, for the last one, Noel, can you explain or describe the surface of the pavement as shown from this particular picture? This is easier because it has told you that this particular pavement is a limestone pavement. So what do you think would have happened or have happened to have created the feature? You describe the surface first of all, and then we will look at what do you think would have happened to have created the feature.
The stone has a lot of cracks and is rough.
Okay, so we're looking at the surface of this particular limestone pavement, and Noel has said that there are a lot of cracks or gaps in between, where once upon a time all of this was just perhaps a block. Correct. That's exactly what has happened. You can see a lot of cracks and rough surfaces now which have been created on the surface of the limestone pavement. What then do you think would have resulted or created such cracks and also the rough surface on that pavement? Ovio.
The reaction between the carbonic acid with rock minerals.
Okay, the reaction of carbonic acid together with the rock minerals. And because this is a limestone pavement, obviously, this is calcium carbonate we're looking at, and water or rainwater would have come in contact with that, resulting in those cracks in between those blocks being created. Okay, those three activities, you double check and you make corrections to. The fourth activity will be what I would want you to do for your homework. You have looked at that particular photograph, which is a limestone pavement. So now for your homework, can you make note of this quickly? I'd like you to make a sketch drawing of the pavement surface, and then you label the ridges of the limestone. That means those blocks that are left standing as clients, and the gaps between those ridges, grikes. When Noel gave us the answer for the surface of that limestone pavement, he said the pavement had a lot of gaps or cracks in between. So those blocks that are left standing, when you sketch, you make a sketch, you label those as clients. And the gap between those blocks that are left standing, you label that as grikes, because clients and grikes are common features also which are formed, especially on limestone areas whereby solution or carbonation has taken place, resulting then in a block standing, which is a grike, and a gap between the blocks referring to as clients. Okay, have you got that information down for your homework? Okay, that will also bring us to the end of the lesson. Okay, class, if you can now stand up. Okay, to the pilot teachers, our keyword for lesson 67 is carbonation. Good afternoon and thank you, students.